if we want to understand where we've come from, the stories that have led us to our present condition, if we want to understand our history, one of the prerequisites is to have a good sense of chronometry. And chronometry, very fancy word, but it really is just the science of the passage of time. Chrono, relating to time, metry, time measurement. And we take many, many things for granted these days. We assume that we know what happened the last 50 years, the last 100 years, and now we're starting to assume we know what happened 10,000 years ago, or what happened to our planet 100 million years ago, or 1 billion years ago. But these are all very, very, very new phenomena. This ability to kind of shine a light on the past. And even the traditional notions of history, the traditional stories of what led to what, the political nations that formed, the migrations of people, and when they happened, that traditional notion of history is even fairly new when you think about just the scope of how long we think humans have now been on this planet. And that traditional notion of history, you can kind of view as the first chronometric revolution. And that first chronometric revolution that gives us this kind of traditional notion of history really just comes out of humanity's ability to write. So writing gives us our first chronometric revolution. Because this was the first time, even though we think humans or human-like creatures have been around for hundreds of thousands of years at this point, they weren't able to keep their stories in a very exact way. They might have had an oral tradition. It might have gone from one generation to the other. But with those oral traditions, things would get lost. And the most important information would get lost is how long ago did these stories start up? And we weren't able as a species to really have a firm understanding of when things happened and how long ago things happened until writing became mainstream and until writing was done in a way that it became permanent. And our best sense of when this happened the first time was by the Sumerians with cuneiform. And this happened right around the 3rd millennia BC, so around 5,000 years before the present time. And this is what some of that earliest writing looked like. This is actually a letter from, I believe, from a king, and you could see it's just highly symbolic carvings. This is what we more traditionally associate with cuneiform, and it was symbolic based, as opposed to now most of our languages are based on phonetics, so you have fewer symbols that can represent more meanings. But this was a huge technological revolution, I could say, for humanity. Because now, with the advent of cuneiform, you now had permanent writing that someone could look at 1,000 years later, 2,000 years later, and if they can decipher the cuneiform, they can get a written testimony of what was happening at that time. And they didn't have to rely on an oral tradition or even guess when that oral story might have started. But writing, since it only happened about 5,000 years ago, so this is 5,000 years before the present, or you could say 3,000 years BC, give or take. That was a start, but this only gave us stories of about 5,000 years old, and even then it was a very spotty historical record. We didn't really get really deep history, depending on where you are in the world, until really the last few thousand years. But it was a start. This was the first chronometric revolution. But what you may or may not realize is that we are, frankly, I believe, at the very early stages of another chronometric revolution that has really just begun to accelerate in the last 50, 60, 70 years. And this second chronometric revolution, second chronometric revolution, I should write revolution up here too. This was a revolution. It allowed us to keep time in a permanent way, to understand things, to not have to talk to the people to whom something happened. We can see their written testimony of it. But the second revolution really comes out of the advent of a lot of our understanding of modern science. So in the late 1800s, you have radioactivity gets discovered by Marie and Pierre Curie. So this is 1900 right here. So this is relatively recent. Remember, we're talking about a species that has been around for several hundreds of thousands of years, and proto-humans have been around for millions of years. And now, only 5,000 years ago, at least as far as we know, was the first writing. And then only a little over 100 years ago was a discovery of radioactivity. So radioactivity. And then the ability to use radioactivity. So radioactivity is interesting. It's this idea that essentially elements can change from one variation to another of an element over long periods of time. So through radioactivity. So they become kind of this natural clock. No one had to go there and set up a timepiece for it. That luckily there are these things that decay at a very predictable rate. So we discover radioactivity a little over 100 years ago. And then over the course of the 20th century, we got better and better, more sophisticated at really understanding radioactivity to be able to use it to measure the times of things. And if you fast forward to the second half of the 20th century, so now say we're at 1950, this is where the second chronometric revolution really took hold. This is where it really took hold, where we started to understand carbon-14 dating. We started to understand some of the other techniques that we talk about where we can start to date older and older things. And what I want to be clear, this was the radioactivity, the understanding of radioactivity was just the beginning of this second chronometric revolution. The second chronometric revolution, which frankly we are still a part of, isn't just radioactivity. It's also understanding the expansion of the universe, the constancy, kind of the speed limit of light. That now lets us to figure out, wow, that background radiation we're getting, that must have been traveling for 13.7 billion years ago. So we can now look at evidence from our environment. And our environment is not just the Earth itself. It's radiation bombarding us from space that allows us to that gives us clues as to not just the age of us, of humanity, the age of species, the age of the planet, but the age of the universe itself. So it isn't just about radioactivity. Radioactivity is a big part of our chronometric revolution. This is what allowed us for the first time, if we have layers on the Earth, people have known for a long time that if we assume that these layers haven't been jostled, that something at a lower layer down here is probably going to be older than an upper layer, because year after year you have deposits if it hasn't been messed up in some way. But no one knew. They said, okay, well, this is relative dating. This is older. This is younger. But we had no way of knowing that, hey, is this 1,000 years old, or is this 1,000,000 years old, or is this 1,000,000,000 years old? But now with radioactivity, now we could start to say, hey, we can date some of the rocks here that are 150 million years old, and some of the rocks here are about 100 million years old. So maybe this fossil of a fish that we're finding, or this primitive fish-like creature right over here, this would be between 100 and 150 million years old. And the only way we were able to do this was with being able to date things using radioactivity. But radioactivity is just a start. As I mentioned, we're getting better and better understanding of cosmology. We're getting better measurements of the universe itself. We're understanding physics at a deeper level. Now we can start to look at the genome and think about how the genome diverges from one species to another and how quickly it changes. So all of these things are just allowing us to get better and better refinements on the chronology. Obviously, this is a start, but you still don't know, plus or minus 50 million years, how old this is and how this relates to other things that you might find. So I just wanted to point this out, that what we take for granted now, the age of the universe, the age of Earth at 4.5 billion years old, humans being around for several hundreds of thousands of years, this understanding is a very, very, very new phenomenon. It's due to the second chronometric revolution that I think we are still a part of. And even the first chronometric revolution, this version of history, and I want to be clear, history was limited by this first chronometric revolution. It was limited by whatever was documented. But now maybe we can expand our notion of history. And a lot of the videos that I've been working on have been for this big history project, which says, hey, before, history was limited by the first chronometric revolution to what was written, by what was testified by people and was made permanent in some way. Now we have chronometry has taken us so that we can understand things into our deep past, before even the Earth has existed. So why not redefine history in a big way, for it to encompass everything, for it to be big history? Anyway, I'll leave you there. And actually, I want to also emphasize that the second chronometric revolution is a big deal. It allows us to transform even our understandings of history. But even this first chronometric revolution, right over here, 5,000 years is still not very long in the entire scope of even human civilization.